Good day to all of you. Solutions for interruption in the upstream of the Sri Lankan power system. That's a problem which we are currently facing, which we will be facing in the next few years. Why? Let's see. The study is because the government are making policies to improve the service sector of the country. Not only that, the government encourages solar penetration and wind penetration. Service sector development means that the industrial sector development decreases. So that means more rotational masses coming as loads are not there anymore because the government and everything focuses on service sector. Solar and wind power penetration also now for example if when you are talking about wind we generate it by a variable frequency generator. Then we convert it into DC and then DC is being converted into AC again. So there is a double conversion and therefore mechanical coupling of inertia is not there. Similarly in solar, we don't have rotational masses. Because of this, the system inertia reduces drastically. And if a problem occurs in the system at this point, there would be more cascade trippings. Therefore, when solar and wind are installed more rapidly in the day-to-day proceedings, as time goes on, that means we are facing a less inertia system. We are moving towards a less inertia system. That means frequent under frequency load shedding could occur. This is a classic example which we have done by using the Sri Lankan power system. We incorporated solar and we tripped a 275 megawatt typical. This was the Aluthge power station, Moratuwa, and we observed the frequency response. Then we did the same by taking away the solar generation and we replaced the solar by conventional generation. You can see the two graphs. If you compare the two graphs, there is a smooth increment of the frequency when there is no solar. But when there is solar, the smooth transition from 48.4 Hz to 50 Hz is not there. So this is an issue which we currently face. But if more and more solar and more wind comes into play, this gets even critical, even worse. Next, what we did was we did the same thing by tripping a 60 megawatt power plant. But this time we made a small difference. We made a small change. We add a standby battery energy system storage so that as soon as the 60 megawatt generation goes out, this synchronized BESS, it won't be giving power when there is no tripping. It won't be giving power. But as soon as the 60 megawatt generation is being reduced or taken out, this gives power and restores the frequency. As you can see in these two graphs, the dotted graph shows that the frequency response without the battery energy system storage, and the solid line graph shows the frequency response when there is the battery energy system storage. So as you can see, there is no load shedding in the solid line. But obviously this isn't practical in most cases because we have to install a huge battery energy system storage. Australia Hornsdale power reserve is a classic example for that. Developed and maintained and commissioned by Tesla Corporation. But here which we did was, we did a simulation for 33 kV feeder from the Ratmalana grid substation. We took a feeder and we manage when the frequency gets down after a certain point, the national grid is taken out and this feeder is being isolated. The frequency is monitored by the PLL and it is being locked, and there is a battery energy system storage to give the power as soon as the national grid is taken out. The classic problem, the issue here, or the issue here is that there is an VSG. This VSG corresponds to the power which is being installed in that feeder. Now, for example, let's say that it's a 10 megawatt solar is being installed throughout this feeder. This VSG is acts as this 10 megawatt solar generation is not solar but a conventional generation. So the VSG provides the required frequency, the inertia to that particular feeder. This is the VSG model that which we have incorporated to the PWM inverter. And as you can see, as soon as the voltage reduces, that means when the national grid is taken out of the system, you can see that the voltage increases back to its nominal value within no time. Have they been installed in other countries? Yes, this battery energy system storage, especially lithium-ion battery energy system storages, are being installed in many countries. For example, in Australia, 100 megawatt generation up to 129 megawatt hours of generation is being installed. Battery energy system storages in around the world are some. Uh, there is one at California, and in the Dornish power system, there is a solar power plant, and it has a battery energy system storage. Fast response in supercapacitors can be also considered as good transient power generating methods. Therefore, to avoid frequent load shedding in the system in various selected feeders, we can incorporate battery energy system storages to shut down, to stop the frequent load shedding process. It's not only that, these battery energy system storages can also, because of the VSG, it can also give us a virtual synchronous generator within that feeder. Not only that, these battery energy system storages can isolate the grid, isolate that particular feeder from the grid, and it can give power during peak hours, so that many gas turbines can be taken into consideration. But the cost plays a major issue. Cost reduction is a major issue. By considering the inflation rate of Sri Lanka and the United States of America in 2026, if we want to have a battery energy system storage for a particular feeder, and here which we have considered is the Ratmalana 33 kV feeder number 7, that requires 3 2.7, not 3, 2.7 billion rupees. So that is a cost aspect, also plays a major role. So it is up to us to select what feeders need a best, what does not. And do we actually need it? Yes, we do need it in the near future, because many solar power penetration happens uh, in the day-to-day life. Day by day solar penetration occurs, and that results in drastic problems in the inertia of the system, as well as in the low voltage side. uh, it gives it overshoots the voltage. So these problems can be resolved by having a battery energy system storage so that it can absorb excess power in the system. So let's not stop here. Let's do our researches and let us move forward with the emerging technology to resolve the power crisis which we will be facing in few years. Thank you. Have a nice day.